Linear regression is a popular data mining technique, not only because it has generally good accuracy, but also because it has an intuitive business interpretation. In this video, we're going to briefly go over linear regression, but look specifically at how the results can be translated into a business meaning. I'm not going to go into the mathematical details of how linear regression works, but I do need to show you some idea of it. Generally speaking, linear regression produces a mathematical equation that you have right here, where you have y, what is being predicted, which is a constant, and then you add various predictors and there's an error at the end. Graphically, what is going on is that if you just have two data points, let's say you have one x value, one predictor, and then y, what you're predicting, and if you were to plot it, the blue dots are where it is plotted. What linear regression tries to do for each x variable, that's each predictor, is to derive a straight line that comes as close as possible to each of the data points as it can. And as close as possible, sometimes it's very close, but sometimes it's farther. There's always some sort of error between the points, and this error, that's this difference, is used to calculate the linear regression equation overall. So that's just a general overview of what the mathematics is doing. But this video, I want to focus more on the interpretation from a business perspective. So statistically, the meaning of linear regression is a linear equation such as what you have here. But the value of this is that it does have an intuitive business meaning. So let's look at an example of the business interpretation of this equation. And our scenario is that we are a wholesale company that sells some sort of wholesale products, and there is a new retail store in town, the major retail company, and we would like to have an estimate of how much sales they would give us in the next month. And let's say that we want to know this because if it's a new retail company that's going to have very low sales, then well, we might just mail them a flyer that we're here and that's it. But if we anticipate that they could have quite high sales, then we'll actually send one of our salespeople to go knocking on their door and introduce ourselves, which costs us more, but which can potentially cause greater conversion. So suppose we have an equation like this based on our linear regression analysis of what a typical new customer like that might give us. And so we get an equation here. And the b's here, these are called the coefficients. They're numbers like 0.23 minus 1.4 and so on. And they are numbers to be multiplied by meaningful factors that could affect how much sales we expect to get from that new retail customer. So the y, what we're predicting, is the new customer purchases. And this equation says that to get a value for that, it equals, start with some constant. For example, 123 euros. And you could think of this as saying that, well, if the company is going to buy from us, let's say baseline, they'll buy at least 123 plus or minus. So you can think that not exactly, but that's a way to think about it. Okay, it's just a starting baseline. They're going to buy at least that much. Then you look at the number of employees that they have. So, and with the idea being that the more employees they have, for example, they have 11 employees, then the more they will likely purchase from us because it means you're a larger volume store. Then we also consider the number of our competitors in their area. So based on where they are located geographically, there are other wholesalers like us. If there are like two other wholesalers relatively near them, then that's going to have a negative effect on how much sales they might buy from us because they would rather go to someone closer to them. Then there might be a factor of, are they a government contractor or not? This is a true false question, where, for example, true, they are a government contractor because typically retailers that contract with the government have quite high volumes of sales relative to those that don't. So that would have a positive effect on increasing the sales they might get from us. And then there might be a question of, have they recently opened their store? And if they only recently opened their store, then they might have a lot more sales because they want to stock up. But if it's not a recent opening, then that would be zero in this case, and that doesn't have an effect. And then when you add these numbers up to get an estimate of the customer purchases, there's always, it's not going to be exact. Maybe adding all these up gives us 2,569 euros. But when we find out actually how much they buy, it's going to be off by a little bit. So let's say there's always some prediction error, which, if is a good model, will be relatively small. For example, it will be just 84 euros off the actual amount, and that will be a relatively good prediction on the scale of 2,000 euros. So the one of the most attractive things about linear regression is that although it gives a mathematical equation as a result, when you look at the business factors that go into that, it's meaningful and that can actually guide business decisions.